helping you stay in the know. This is the PSN News Network and psnnews.net. From around the country and around the world, we bring you the latest news from the Associated Press. The PSN News Network will keep you informed. Updates are also available throughout the day on www.psnnews.net. The PSN News Network, psnnews.net, and the Associated Press. When you want to know.
Black holes, the cosmos, space and time travel, science and technology. This is Science Fantastic with Professor Michio Kaku.
Great Scott. I know, this is heavy.
Theoretical physicist, the co-founder of string field theory, author of the international bestsellers Hyperspace, Visions, and Parallel Worlds. Now, profiling the latest cutting-edge developments in science. Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. You know, the year 2016 came down as one of the historic years in politics. However, most people have spent their time looking at the floor, putting their head down, but not looking up. So this is what I want you to do. Look up. And you'll see that there's a glorious universe out there. In the year 2016, we made incredible breakthroughs in astronomy. We discovered gravity waves, which may open up a whole new way in which to look at black holes and the universe. We discovered a planet going around the nearest star to the Earth, Proxima Centauri. The planet is a hop, skip, and a jump from the planet Earth, and one day perhaps we'll live on that planet. And then we'll say a few things about Mars, a few things about Pluto, and the exploration of the universe. Our special guest today is our favorite astronomer, Dr. Ken Croswell, author of the book, The Alchemy of the Heavens, Searching for Meaning in the Milky Way. Well, before we bring him on, let me just mention that you should go to my website. It's mkaku.org, mkaku.org, or go to my Facebook site. We have 3 million fans on Facebook, or Twitter. We have 500,000 fans on Twitter, and find out what all the excitement is about. My latest book is called The Future of the Mind, which hit #1 on the New York Times bestseller list, all about what the military is doing, probing the secrets of the living brain as we begin to record memories, as we begin to send emotions perhaps on the internet, as we begin to hook up the brain of injured, wounded warriors from Afghanistan and Iraq to mechanical exoskeletons, giving them the gift of life once again. Or go to my other books, Physics of the Impossible, talking about time travel, talking about teleportation and everything you see in the movies. Or my other book, Physics of the Future, all 3 of them New York Times bestsellers, talking about the next 20, 50, next 100 years in technology, in medicine, in space travel, in computers and robotics, all of that in Physics of the Future. And once again, go to my website, mkaku.org, which summarizes it all. Well, once again, today in this hour, we're going to talk about the top stories of 2016 and what a year it's been for the universe. First of all, 100 years ago, it was 100 years ago in 1916 that Albert Einstein took his theory of relativity, only a year old, and predicted gravity waves. Not just light waves, not radio waves, but gravity waves from outer space. And one day we will use them as gravity telescopes. Gravity telescopes that'll give us baby pictures of the infant universe as it was created over 13 billion years ago. This is incredible, being able to use a new kind of telescope to peer into the heart of black holes. And then we'll say a few things about Proxima Centauri, the closest star to the planet Earth. Believe it or not, the closest star to the planet Earth has a planet going around it, which is Earth-like. It has a mass just 1.3 times the mass of the planet Earth, and we think that it maybe one day will send a probe to the nearest planet with an Earth-like planet going around them. In fact, if you see the movie Passengers, starring all these Hollywood A-listers, it talks about a 120-year voyage to one of these planets, and perhaps Proxima Centauri will be the star, which is the destination for that starship. Well, once again, our special guest today, Dr. Ken Croswell. Let's take a short commercial break. And after the break, we're going to explore the top stories of 2016. What happened with Pluto, with Mars, with Proxima Centauri, with black holes, with gravity wave detectors, all of that as we continue our discussion of the universe, the biggest discoveries in 2016. And if you want to get on Science Fantastic, give us a call at 866-323-2129. Give us a call.
This is Science Fantastic. For more information on this and other great talk programs, go to talkradionetwork.com.
I want to talk with you about evolution. It's actually a board game, and it's called Evolution: The Beginning. A few months ago, I played for the first time. I must say, it's a very clever game, and it's a new game, so I wanted to make sure that dear old Dad could play this game with the kids at Christmas. He can. Here is the goal of the game. Eat as much food as possible. Yes, to survive, you must eat. And to eat food, each player takes turn creating and evolving their very own species. There's hundreds of ways to evolve your species, and the fun part is, it's up to you. Evolution: The Beginning is based on science. Your species must adapt and change in order to be competitive, just like in life. Evolution: The Beginning is only at Target stores. So when you're at Target this week for last-minute Christmas gifts, go to the game section and get Evolution: The Beginning. It's a great holiday gift for your family, and it's all at Target stores. Evolution: The Beginning.
Hello, I'm Roy Masters. In spite of the fact I dislike asking for financial support from my listeners, I realize the consequence of failing to do so. I will have denied my listeners the second chance to express the grace of paying forward the benefits they receive through my radio program and the Foundation of Human Understanding, the organization I founded over 50 years ago. Your support will make a vital difference with the pledge as little as 63 cents a day throughout this year. Consider a donation of $19.95 per month or whatever you can afford, and help me help others, especially our returning heroes. So for the sake of the military and millions of broken lives, if you haven't done so already, pay it forward, the benefits which you've received throughout the years from one crying in the wilderness. Go to FHU.com/donate, FHU.com/donate. Thank you from the bottom of my heart.
The Foundation of Human Understanding is a 501c3 church.
Having a place to go after school will make you a better student. Having an outlet to express yourself will make you a better artist. Having something to do together will make you a better family. At The Y, we're helping build better friends, listeners, writers, swimmers, scientists, and musicians, one chance at a time. Give the gift of opportunity. Donate to The Y at ymca.net/give. The Y, for a better us.
Do you worry a lot? Whether you're a college student, busy professional, parent, or grandparent, ongoing stress and elevated levels of the stress hormone cortisol can rob your memory, your health, and your future. Now you can combat the effects of stress and anxiety while improving your memory and recall at the same time with the dietary supplement Calm and Clever. Studies show that the ingredients in Calm and Clever reduce cortisol by as much as 30% in 1 to 2 weeks. Call 1-800-758-8746 or calmandclever.com.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. With us on the line once again is our favorite astronomer, Dr. Ken Croswell of Berkeley. And we're going to sum up the year 2016 in the heavens. Well, 2016 was quite a year, but instead of looking down all the time and putting your head in the ground, look up. look up and see that there's a glorious universe out there. And there's been an enormous number of breakthroughs in our understanding of our backyard. The Milky Way galaxy, we're going to talk about gravity waves. We're going to talk about exoplanets, Pluto, Mars, galaxies, you name it, with astronomer Ken Croswell, author of The Alchemy of the Heavens, and also subtitled Searching for Meaning in the Milky Way. So, Ken, glad you could be on. Once again, science, fantastic.
Glad to be here, Michio.
Okay, well, let's just jump right into some of the big stories. In fact, there's probably a Nobel Prize waiting for the physicists who nailed down gravitational waves. So tell us a little bit about all the excitement that's being generated in the field of physics and astronomy.
Yes, this was a great discovery that actually occurred on September 14th, 2015, but the announcement didn't come until February of 2016, so that's why we're talking about it in 2016. Two black holes orbiting around each other spiraled together, got closer and closer and closer until they merged into one even bigger black hole. One of the black holes was 36 times more massive than the sun. The other black hole was 29 times more massive than the sun. And they formed a black hole that was 62 times more massive than the sun. Now, if you add up those two numbers, 36 and 29, you won't get 62, you'll get 65. So what happened to the three solar masses, the missing three solar masses? Well, it was converted into energy via Albert Einstein's famous equation, E equals mc squared. The mass, m, in that equation was converted into energy and radiated. And we detected the gravitational waves from that merger on September 14th, 2015. As the waves passed through the Earth, they caused the detectors that detected the gravitational waves to vibrate ever so slightly by less than the size of a proton, if you can believe that. And yet they were able to detect it. So this is definitely an amazing discovery. Now, nobody really doubted that gravitational waves were out there. And in fact, decades ago, astronomers had discovered two neutron stars orbiting each other, and their orbit was decaying in a way that agreed with Albert Einstein's general theory of relativity. But this is actually a direct detection, the first direct detection of gravitational waves as predicted by Albert Einstein's general theory of relativity.
And isn't that amazing? It was 100 years ago, 100 years ago in 1916, that Albert Einstein predicted these gravity waves, but he despaired of ever being able to prove it in his lifetime. Gravity waves are so faint that he himself said that in his lifetime he's not going to be able to see the verification of that prediction. But bingo! 100 years later, we can now confirm that Einstein's theory was correct on the question of gravity waves. Now, some people say, well, so what? Let's say, for example, that the sun were to disappear right now. Right now, the sun were to disappear. According to Newton and according to Einstein, how long would it take for us to feel the effect of a disappearing sun?
Well, light travels at the speed of light, and so does gravity, according to Einstein. And so basically we would all get flung off into the void, all the planets, Mercury, Venus, Earth, Mars, and so forth, and we would also lose all the light from the sun. But it would take about 8 minutes for us to notice that there was something very wrong with the sun, since it takes light 8 minutes to travel from the sun to the Earth.
Okay, and also some people say that every time we discovered a new kind of radiation into outer space with a telescope, it revolutionized our understanding of the universe. 400 years ago, Galileo aimed a telescope to the heavens and using optical radiation found out that there was a whole universe out there waiting to be discovered. Then during World War II, we detected radio waves with radio telescopes, and that gave us a glimpse into the heart of galaxies. And now some people are saying we're now witnessing the third great revolution, gravity telescopes. Maybe within a few decades, LISA will be sent into orbit, which will detect gravity waves from the Big Bang itself. Isn't this incredible? I mean, the potential of looking into the heart of black holes and perhaps into creation itself using a new kind of telescope. gravity waves instead of radio waves and instead of light waves. What are your thoughts?
Well, certainly in the future, in the far future especially, I think we can count on gravitational wave detection to tell us more about the most extreme conditions in the universe. For example, two black holes merging together, or a neutron star and a black hole merging together. I would point out that I wouldn't call this the third great revolution in astronomy. There have been a number of non-optical types of radiation that have really advanced our understanding of the universe. For example, infrared tells us quite a bit about the universe. X-rays tell us about black holes. In fact, the very first black hole ever detected, Cygnus X1, was revealed by black holes. Was revealed by X-rays emitted by hot gas falling in to the black hole. So there are many non-optical forms of radiation that have told us a lot about the universe, and gravitational waves are going to be one of those forms.
Okay. Well, moving right along, because we want to summarize some of the top stories of the past year, let's talk about Proxima Centauri. It's a star that it doesn't roll off the tongue very easily of most people. However, in the future, it could, in some sense, contain our destiny. There's a movie called Passengers, which people are talking about, where scientists are able to invent starships, and we can go to exoplanets orbiting other stars. But tell us a little bit about this discovery of an Earth-like planet orbiting around Proxima Centauri.
Yes, this is certainly the greatest astronomical discovery of 2016. It's an Earth mass planet. It may or may not be Earth-like. We don't know. Proxima Centauri is a very nearby star. In fact, it is the nearest star to the Sun, located only 7,000 times farther than the planet Pluto. It's 4.24 light years away. It's a very dim star. It's a faint star. It's a cool star. It's a red dwarf star. It's so dim that despite its proximity, it was discovered only in the year 1915, which, strangely enough, is the same year that Albert Einstein came up with the general theory of relativity. It is in orbit around two much brighter stars called Alpha Centauri A and B. And the excitement of this year is, as you just noted, the discovery of an Earth-mass planet that is in the habitable zone of Proxima Centauri. Now, because Proxima Centauri is so faint and so dim, the planet is actually much closer to its star than Mercury. The planet Mercury is to the Sun. But that's perfect because the star is so faint. And so this planet is actually in the habitable zone. It goes around the star every 11.2 days. So that's a lot faster than we do. We, of course, take a year to go around the Sun. Mercury takes 88 days to go around the Sun. This planet is so close to its star, just 4.5 million miles from its star, that it takes 11.2 days to go around its star. And so that raises the hope that maybe, and I emphasize maybe, it could have liquid water on its surface. And if it does have liquid water on its surface, then it could conceivably harbor some form of life, because we do know that the Alpha Centauri star system is fairly old. It's probably a bit older than the Sun. So there's been plenty of time for life to evolve on this planet if it has water and if it has other conditions that are good for life. But the really big unknown is we just don't know whether this planet has water or not.
Okay, well, even school children know that Alpha Centauri is supposed to be the closest star to the Earth, but what's the relationship now between Alpha Centauri and Proxima Centauri?
And that's another discovery of 2016. We have long thought that Proxima Centauri was orbiting around Alpha Centauri A and B, and now we've got the proof. And here are the figures. Proxima Centauri is located 4.24 light years from Earth. Alpha Centauri A and B are located 4.37 light years from Earth, so just a little bit farther. The two are separated by 13,000 times the distance between the Earth and the Sun, so they're very far apart. And so some people have said, well, maybe they're not really orbiting each other. But now we have new precise velocity information that indicates that, in fact, Proxima is traveling through space at almost exactly the same speed and in almost exactly the same direction as Alpha Centauri A and B. So the little star is indeed gravitationally bound to the big bright stars, Alpha Centauri A and B. Moreover, this new work, even for the first time, reveals the orbital period of Proxima Centauri around Alpha Centauri A and B. It's a long period, as you might imagine, given their huge separation, 550,000 years. That's how long just one orbit of Proxima Centauri takes around Alpha Centauri A and B.
Well, you know, fans of Star Wars, the movie, had to withstand the criticism of scientists who said, what? Luke Skywalker looks up in the sky and sees a double star system? Such a system would be unstable. Well, here we have a triple star system, right?
Right.
And it seems to be relatively stable. So doesn't that mean that the critics of Star Wars were in some sense wrong? What are your thoughts?
Well, the Star Wars scene involved a planet going around a double star, which we didn't know of it at the time that movie came out. But in fact, we have since discovered planets going around double stars, just as shown in that movie. So any such criticism was premature. You know, we astronomers, or another way to put it is, I think the universe is often more imaginative than the astronomers are.
Okay, and talking about this Earth mass planet going around Proxima Centauri, right? What do we know about it other than its mass and its period? Do we know anything about its atmosphere, whether it contains water molecules or oxygen? Do we know anything about the composition of its atmosphere?
Nope. And that's the final answer. We don't know a thing. We don't know if it has an atmosphere. We don't know if it has any water. We don't know what's in its atmosphere, if it does have an atmosphere. All we know are its mass and its period and its distance from the star. And from that, we can infer that if it has an atmosphere, that it's got a pleasant climate. But the fear is maybe it doesn't have an atmosphere. You know, maybe it's like the moon.
So now I want to talk with you about evolution, the beginning. It's actually a board game. Yes, it's a new board game you can play with your family, and it's called Evolution, the Beginning. A few months ago, the inventors of this game came by to visit. They wanted to show me how to play, and I told them very clearly, I want to make sure that dear old Dad can play this game with his kids when they open it Christmas morning. So we talked about the goal of Evolution, the Beginning. It's actually quite simple. Eat as much food as possible, because food counts for points in this game. To eat the food, each player takes turns creating and evolving their very own species. You can create long-necked herbivores that eat plant food, or you can create speedy carnivores that eat other organisms. There are hundreds of traits. It's up to you to decide what to create, and that's the fun. What I love is that Evolution, the Beginning is a game based on science. The game actually teaches about evolution because your species must adapt and change in order to be competitive and survive. The environment is dynamic. So every round brings new challenges and opportunities. You'll succeed if you can adapt to the changing environment. The goal of evolution, as in real life, is to be the fittest. And it's the same with this game, Evolution, the Beginning. So when you're at Target this week shopping for last-minute Christmas gifts, go to the game section and get Evolution, the Beginning. It's the perfect holiday gift for your family. You'll find it at all Target stores. Evolution, the Beginning. Let's take a short commercial break, and after the break, we're going to continue with Science Fantastic with Professor Michio Kaku. Keep the calls coming. If you want to get on Science Fantastic, if you want to have your thoughts heard on 100 radio stations, give us a call at 866-323-2129. Leave your name, call letters of the radio station you're listening to, and the city you're calling from, and perhaps your thoughts could be heard on national radio. So once again, our special guest today, is Dr. Ken Croswell, author of Alchemy of the Heavens. So stay tuned as we continue to explore the top stories of the past year.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to sum up the big stories in astronomy in the year 2016. You know, when we think of 2016, we take a look at what happened in politics, with the environment, with all sorts of things happening on the planet Earth. But we forget the fact that there's a huge universe out there, and it doesn't wait for anybody. It's evolving, and we have more discoveries coming in every year. So far, we talked about the discovery of gravitational waves. We talked about the discovery of an Earth-mass planet going around Proxima Centauri, the nearest planet to the Earth. But there are other breakthroughs that were made in 2016. First of all, in 2015, we had the New Horizons mission, which flew around Pluto. And information still keeps pouring from as we analyze the flyby that took place. So, Ken, could you sort of summarize briefly what we learned from the New Horizons flyby of the planet Pluto as information is still being digested a year later?
I'd be happy to, because Pluto is my favorite planet, and the New Horizons spacecraft was a total success. It gave us our very first close-up view of Pluto ever. Prior to this mission, we had images, very blurry images from the Hubble Space Telescope of what Pluto looked like. But now we have it in close-up. And Pluto is an orange planet. It's got a big white heart on it, which really surprised and delighted everyone. That heart has been named for the discoverer of Pluto, Clyde Tombaugh. Clyde Tombaugh discovered Pluto in 1930. The New Horizons spacecraft measured the size of Pluto precisely, 1,477 miles, and it turns out, guess what? Just as we were told back in grade school, Pluto is, in fact, the largest object going around the sun beyond the orbit of Neptune. It is larger than anything else out there. Back in 2005, you may recall that an astronomer discovered Eris, which is even farther than Pluto. He claimed it was definitely bigger than Pluto. He said, if it's not larger than Pluto, then I'll eat my telescope. Well, guess what? It's not larger than Pluto. Pluto is larger than Eris, and I do wonder how he likes the taste of a telescope, because I assume he is having telescope stew for dinner. Let's see, what other results from the spacecraft? The spacecraft discovered mountains on Pluto, 2 miles high, as high as the Rocky Mountains, that are made of water ice, because at Pluto's very frigid temperature, which is nearly minus 400 degrees Fahrenheit, water ice is as hard as rock, and so it can form mountains miles high. Also, the spacecraft looked at Pluto's 5 moons. Pluto's 5 moons going around it. The largest moon, called Charon, has these enormous canyons that really surprise people. They're much deeper, much longer than the Grand Canyon in Arizona. They're up to 4 miles deep and hundreds of miles long. So a lot of great discoveries from the New Horizons mission that came out last year.
Okay, and you mentioned this strange heart-shaped object, a plane of some sort, on the surface of Pluto. We've never seen that in the solar system before. So what could cause this heart-shaped formation, which occupies roughly 30% or so of the surface of Pluto?
Yeah, that heart is bigger than the state of Texas. It's a very big feature, very prominent. Just look at a picture of Pluto from the New Horizons spacecraft, and you'll see it. The thinking is that that area, which is white, is probably made of frozen gases, frozen nitrogen, maybe frozen carbon monoxide. Nitrogen is the main gas that makes up our atmosphere. It's also the main gas that makes up Pluto's atmosphere. And so it's entirely possible that that region of Pluto, that heart, that big white heart, consists of frozen nitrogen, frozen carbon monoxide. And in fact, we have detected what looked to be glaciers of frozen nitrogen on the surface of Pluto. Again, here on Earth, nitrogen is a gas, but Pluto is a lot colder than Earth. It's, again, almost minus 400 degrees Fahrenheit, and so most of the nitrogen on Pluto is frozen solid, just as if you could somehow lower the temperature of Earth to hundreds of degrees below zero, the gas in the atmosphere would freeze and actually snow onto the surface and become
Okay, Ken, once again, we have to take a short commercial break, and after the break, we're going to continue a discussion of the universe in 2016. What kinds of revolutionary discoveries were made concerning the universe? Once again, this is Science Fantastic with Professor Michio Kaku. Keep the calls coming. If you want to get on Science Fantastic, ask a question, give me a call at 866-323-2129. Let's take a short commercial break and continue our dialogue with Dr. Ken Croswell, author of the book, The Alchemy of the Heavens. So give us a call, 866-323-2129.
This is Science Fantastic. For more information on this and other great talk programs, go to talkradionetwork.com.
Want to invest but don't know what to do? In search of fixed double-digit rates immune to currency, real estate, and stocks? Discover the alternative asset Barron's Magazine describes as lucrative and safe. An investment immune to Fed manipulation and low interest rates. Request your investor's guide. Call Cornerstone at 800-222-INFO. 800-222-INFO. That's 800-222-INFO.
As a business owner, or CEO for that matter, are you frustrated with the money you're wasting on advertising? How do I know it's being wasted? Because you see your advertising as an expense. I started my company because I was tired of seeing passionate business owners waste advertising dollars. So what if I could show you how to make your advertising a profit center in 30 days, guaranteed? I know what you're thinking. That's bull. Then challenge me. At no cost to you, I'll show you how to make your advertising a profit center, not an expense. If this is important to you, call me. I'm Dan Glaviano.
If you spend $10,000 to $80,000 a month on advertising, Dan will show you how to make your advertising a profit center, not an expense. Dan only works with one business in any given category. Find out if your category is still available. Visit gottacalldan.com. gottacalldan.com. That's gottacalldan.com.
I want to talk with you about evolution. It's actually a board game, and it's called Evolution: The Beginning. A few months ago, I played for the first time. I must say, it's a very clever game. And it's a new game, so I wanted to make sure that dear old Dad could play this game with the kids at Christmas. He can. Here is the goal of the game. Eat as much food as possible. Yes, to survive, you must eat. And to eat food, each player takes turn creating and evolving their very own species. There's hundreds of ways to evolve your species, and the fun part is, it's up to you. Evolution: The Beginning is based on science. Your species must adapt and change in order to be competitive, just like in life. Evolution: The Beginning is only at Target stores. So when you're at Target this week for last-minute Christmas gifts, go to the game section and get Evolution: The Beginning. It's a great holiday gift for your family, and it's all at Target stores. Evolution: The Beginning.
Are you a baby boomer? Afraid of stocks and commodity prices? Want to invest but don't know what to do? Discover the alternative asset class Barron's Magazine describes as both lucrative and safe. Discover high yields without market volatility. Request your investor's guide. Call Cornerstone at 800-222-INFO. 800-222-INFO. That's 800-222-INFO.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today, once again, is astronomer Ken Croswell, author of The Alchemy of the Heavens, talking about the big stories of 2016. Like I said before, most of us spend all our time looking at our feet, staring at the ground, wondering what's next, without realizing that there's a whole universe out there. So look up. look up and see that there's a glorious universe out there. And today we're summarizing some of the top stories in astronomy. Well, Ken, we talked about Pluto and what's beyond Pluto. Most people would say that what's beyond Pluto is nothing but debris and perhaps comets and gigantic ice cubes of some sort. However, some scientists at Caltech are now saying no, there's a gigantic planet out there, perhaps the size of Neptune, a giant gas giant way out there. Now, this is not Planet X. I get a lot of emails saying that we're going to be hitting for doomsday in the future as a gigantic planet comes barreling down the solar system and gobbles up the Earth. That's not going to happen. However, there really is something out there, right? Perhaps the size of Neptune. What are your thoughts about this conjecture?
Well, it is only a conjecture. And the fact is, over the years, over the decades, in fact, for more than a century, astronomers of various sorts have predicted unseen planets in the outer part of the solar system. And with the single exception of Neptune and Pluto, we've never found those planets. And if you restrict yourself to really big planets, then really the only planet that was ever predicted in advance of its discovery is the planet Neptune, because Pluto and Eris are not big planets, they're small planets. As to whether this new object that may exists, I don't know. I will believe it when it actually turns up. Also, since we were talking about general relativity earlier, keep in mind that in the 1800s, people noticed that the planet Mercury was off course, and they proposed that a planet existed inside the orbit of Mercury to perturb the orbit of Mercury. But it turned out, and they even named that planet the planet Vulcan. They even observed, supposedly, the planet Vulcan. But it turned out that no, Mercury's orbit wasn't off at all. It was simply the effects of general relativity on Mercury's orbit, which manifest themselves greatest closest to the sun. So I do not know whether this big proposed planet exists in the outer solar system. We will find out as the years go on.
Okay, well, summing up some of the big stories of 2016 in astronomy, let's say a few things about Mars. Mars, within 25 to 30 years, some scientists are predicting there could be a traffic jam around Mars as astronauts from at least 3 different agencies and companies circle and orbit Mars and giving us the first manned landing. First, we have NASA. NASA is backing the SLS booster rocket and the Orion space module, a contraption that should go to the moon perhaps in the next decade as a trial mission to go to Mars sometime in the 2030s. Then we have Elon Musk of SpaceX, the billionaire entrepreneur who says, hey, wait a minute, he can modify his Falcon rocket and he will beat NASA. He wants to send a rocket to Mars unmanned in just 2 years' time. And he wants to create a city on Mars. Forget about an outpost like in the movie The Martian. We're talking about a city of 1 million people, says Elon Musk. And then we have Boeing aircraft, not to be outdone. Let's take a short commercial break. And after the break, let's talk about what it's like to actually live on Mars. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 866-323-2129. Just leave your name, call letters of the radio station you're listening to, and the city you're calling from, and perhaps your question will be heard on over 100 radio stations that carry Science Fantastic. So, give us a call.
You're listening to Science Fantastic with Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is our favorite astronomer, Dr. Ken Croswell, author of the book The Alchemy of the Heavens, Searching for Meaning in the Milky Way. And we're talking about summing up some of the big stories in 2016. One big story that hit the headlines was the fact that not one, not two, but three 3 organizations or companies have now targeted Mars for a manned mission. Forget about sending a probe or a lander or a rover on Mars. We're talking about humans, a la Matt Damon, walking on the surface of Mars sometime in the 2030s. We have NASA laying out a 3-pronged program to begin the exploration of Mars with the SLS booster rocket and the Orion space module. We have Elon Musk of SpaceX, the entrepreneur, the billionaire, who wants to modify the Falcon rocket so he could reach Mars and create a city on Mars of 1 million people, starting with 1,000 rockets to go to Mars with 100 passengers each. Incredible. And then we have Boeing aircraft, not to be outdone. Yes, even Boeing is looking at the possibility of their sending a manned mission to Mars. Now, of course, creating a city on Mars is not as easy as you might think. The movies make it so simple, right? But Ken, tell us a little bit about what the climate is really like on Mars, and what would it be like to actually try to create a colony? What kind of dangers would astronauts face?
It would be very difficult because Mars, although the best planet in the solar system aside from Earth to live on, is still very hostile. It would be, in fact, more hostile than living in Antarctica. Mars is a very cold and dry planet with a very thin atmosphere. So you would need to protect yourself from the elements, or from the cold certainly. You would need to bring air, or else extract air from the rocks. One thing Mars does have in abundance, though, is water ice beneath the surface, especially in the polar regions and at the high latitudes. So there is plenty of water there. It's just all frozen. But Mars is a very hostile planet. Even as you look at other planets in the solar system and you think they're really awful, well, Mars looks good in comparison to them, but compared to Earth, it's still a very difficult place to live.
And also getting to Mars is no fun either, right? 9 months minimum to go to Mars, 9 months to go back. And there's a Hollywood movie called Passengers, about 120-year mission to a distant planet. That's an awful long time to spend in outer space, even if you are suspended in a pod of some sort. So Ken, it's not going to be easy beginning the colonization of Mars, right? It's not like a Sunday picnic. You have weightlessness, radiation, micrometeorites, huge temperature differentials, lighter gravity, you name it, right?
That's right. It will be difficult. And just think, even today, how few people live in Antarctica, and they're almost entirely scientists. So I suspect the number, I'd be very surprised if in our lifetimes there's 1 million people living on Mars.
Yes, and then how do you begin to terraform Mars and make it livable? Elon Musk has dropped hints that you can nuke the ice caps. That is, drop hydrogen bombs in an airburst over the ice caps so that you would reduce fallout, but still using nuclear weapons to begin the process of melting the ice caps of Mars so that liquid water flows on the surface of Mars once again. Well, what are your thoughts about whether or not it would be easy to begin the process of turning Mars into an Earth-like environment, just like H.G. Wells once envisioned the Martians would invade the Earth and turn Earth into a Martian-like planet? What are your thoughts?
Well, in order to make Mars more Earth-like, it needs to have a thicker atmosphere so that it can trap more heat from the sun. And so anything that can be done to give Mars more air would be a good thing. I don't, however, approve of nuking the planet. I don't think that's a great idea. But certainly the planet, right now, it has such a thin atmosphere, in fact, less than 1% the surface pressure of Earth, that the greenhouse effect on Mars raises the temperature only about 10 degrees Fahrenheit. Now compare that with Earth, where the greenhouse effect raises the temperature 60 degrees Fahrenheit. So clearly Mars needs a thicker atmosphere, a more pleasant climate, but it's going to take probably centuries to pull something like that off.
Okay, and you probably saw the movie The Martian, right? What are your thoughts about how realistically it portrayed some of the hazards that our astronauts would face, especially if they're left stranded on the red planet? Any thoughts?
Well, it's a very, space in general is a very hostile environment. I mean, we get used to the safety of air travel, you know, how safe air travel is. but space travel is much more dangerous, and living on Mars would it would be a risky thing, definitely.
And also in the movie Passengers, starring all these Hollywood A-listers, it talks about suspended animation for 120 years. However, if you do the math and you try to calculate Earth-like planets that are close to the Earth, and you're traveling, let's say, at a good fraction of the speed of light, it would probably take you longer than 120 years to reach your destination, right? What are your thoughts about how far away these planets are, these exoplanets?
Depends how fast you're traveling and how close the nearest Earth-like planet is. Maybe if that one around Proxima Centauri is in fact not just Earth mass but Earth-like, well, you could do it in 120 years. In fact, you could probably do it in 20 years because that's only 4.24 light years away. But we don't know at this time how many planets out there are similar to Earth in terms of having pleasant climates, good atmospheres, and liquid water on their surfaces.
Okay, well, unfortunately, our time is up. So, Ken, once again, thank you so much for being on Science Fantastic.
You're very welcome.
Once again, our special guest today is Dr. Ken Croswell, author of a number of great books, including The Alchemy of the Heavens, Searching for Meaning in the Milky Way. And you've been listening to Science Fantastic with Professor Michio Kaku. If you want to get on the air, give us a call at 866-323-2129. All we ask is, when you get the recording, all we ask is that you leave your name, call letters to the radio station, and the city you're calling from, and perhaps you can get on Science Fantastic. So give us a call. 866-323-2129 is the number to call. And once again, on every week on Science Fantastic, we probe the cutting edge of science. Good day.
You're listening to Science Fantastic with Professor Michio Kaku. Black holes, the cosmos, space and time travel, science and technology. This is Science Fantastic with Professor Michio Kaku.
Great Scott! I know, this is heavy.
Theoretical physicist, the co-founder of string field theory, author of the international bestsellers Hyperspace, Visions and Parallel Worlds. Now, profiling the latest cutting-edge developments in science. Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because this hour is your hour. This is the time when you can get to the telephones and call 866-323-2129. All we ask is that you leave your name, call letters of the radio station you're calling from, and the city you're calling from, and perhaps your thoughts could be heard on over 100 radio stations that carry Science Fantastic. Hey, maybe you're having dinner with the kids one day, and the kids ask you a question from their homework assignment that leaves you stumped. What are you going to do? Just sit there and look dumb? No. You're going to be smart. You're going to get to the telephones and call 866-323-2129. And hey, while you're at it, put them on the telephone and they can ask a question or make a comment and get on over 100 radio stations that carry Science Fantastic. No question is, quote, too dumb or too stupid to put on national radio, because sometimes the dumbest questions are the most profound of all. In fact, there was a 16-year-old boy years ago who asked a simple question: can you outrace a light beam? It took him 10 years to finally crack that problem. His name was Albert Einstein. And when he cracked that problem, he changed world history. The energy source of the stars, E equals mc squared, the energy of the atomic bomb, all of it comes from a 16-year-old boy who asked a simple question: can you outrace a light beam? And then there was a 23-year-old gentleman years ago who asked another dumb question, and that is, does the moon fall? Well, believe it or not, the answer is yes. The moon does fall around the planet Earth. It's in free fall. In fact, you are in free fall when you walk across the room. You are falling, then you're hopping, falling, and hopping, and that's what we call walking. And when this Isaac Newton then calculated the rate at which the moon fell around the planet Earth, he realized, bingo, he had cracked the biggest problem in all of astronomy, the motion of the planets. He could calculate the motion of comets. He could calculate the motion of asteroids and planets just because he asked himself a simple question. Does the moon also fall? Also, go to my website. It's mkaku.org, mkaku.org. We have 3 million people on Facebook and 500,000 people that take Twitter. So find out what all the excitement is about by going to my website, mkaku.org. I have 3 New York Times bestsellers. The Future of the Mind hit #1 2 years ago on the New York Times bestseller list, all about telepathy, telekinesis, recording memories, uploading memories, all of that we can do using advanced physics. Also, Physics of the Impossible talks about time travel, talks about warp drive, starships. Physics of the Future talks about the next 50 to 100 years when we might have robots, artificial intelligence, cures for cancer, space travel. All of that contained in my books. But it all starts with you. It's nothing without you. So I'm urge you to call 866-323-2129. Okay, well, let's move right along and take the first listener phone call.
Yes, this is Robert calling from Charleston, West Virginia. I hear you on WCHS radio. And my question I'm contemplating is the communication development over the years has been by way of fiber optics, cable, and satellite. When whoever goes to Mars, I understand it takes 9 minutes or more for the signal to return. And I'm wondering, could a laser somehow be pinpointed by computers and such so that you could have instant communication both ways? Thank you.
Well, the short answer is no. According to Einstein, and we see no deviation from this in our laboratories, the fastest velocity in the known universe is the speed of light. Laser light, even though it sounds magical because it is coherent radiation, laser light is light. It travels at the speed of light. In fact, in our physics laboratory, not too far where I'm sitting right now, we actually have fiber optic cables, and we actually calculate how long it takes to go from your left hand to your right hand. Believe it or not, it takes about 1/1000th of a second. 1/1000th of a second for light to go from your left hand to your right hand on a fiber optic cable. And we actually measure that right on a tabletop because we have the electronics to do that. In fact, when you look at yourself in the mirror, you're not really looking at yourself as you really are. You're looking at yourself as you were 1/1000th of a second ago. Now, when you communicate with the moon, it takes about a second for radio waves to go from the Earth to the moon. Mars, it takes about 20 minutes approximately, depending upon where Mars and Earth are located in the solar system, but about 20 minutes for a phone conversation, which is really quite annoying if you want to know what's, quote, really happening on Mars. And this is going to be a problem for the astronauts. Laser light doesn't help you at all because laser light also travels at the speed of light, and therefore we're going to have a problem. Now, in Star Trek, they communicate across the galaxy using something called subspace communicators. Well, that's all psychobabble because there's no such thing as subspace communicators, at least not that we know of with the current understanding of the laws of physics. That's not to say that the laws of physics can't be changed in the future as we know more about the limits of Einstein's theory. But at the present time, modern physics says that light in all its forms travels at the speed of light, so our astronauts are just going to have to get used to it. That radio signals will take on the order of 20 minutes to go from Mars to the planet Earth. Okay, well, let's move right along to the next listener phone call.
My name's Brian. I listen in Chattanooga, Tennessee on WGOW AM and FM. My question is, it seems that one of the most prevalent problems for making any more significant advances in a lot of either time travel, space travel, which could be one and the same, is an energy source. Are there any theoretical energy sources, things that are being tested, things that have been tested and proven? Just curious. Thanks.
Well, I think you hit the nail on the head. When you watch a science fiction movie and you see time machines, you see jetpacks, you see ray guns, you say to yourself, well, gee, that's really neat. How come I can't get one at the store? Well, the problem is energy. First of all, you need a portable power pack to energize a jetpack and a ray gun. We actually have laser beams more powerful than the ray guns you see in science fiction movies, and we can create a jetpack, but the problem is to store large amounts of energy into a very small volume. A jetpack, for example, was first explored by the Nazis during World War II. The Nazis used hydrogen peroxide to create a jetpack by which Nazi soldiers could go across rivers that had bridges that were blown up. And that's one very practical application, but the problem was portable power pack. The hydrogen peroxide thing on your back only lasted for just a few minutes. It was not a weapon of war. It was only a way to navigate across obstacles. And again, the problem is the power pack. Same thing with the ray gun. Same thing with many other devices you see in science fiction. Now, when you talk about time travel, you're talking about a whole new realm of energy. You're talking about what is called the Planck energy. The Planck energy is a quadrillion times more powerful than what we find with the Large Hadron Collider, the largest machine of science outside Geneva, Switzerland. So in other words, even though we physicists can begin to calculate what a time machine might look like, with a capital M, what a time machine might look like, we have problems with the energy. Basically, the energy you need is comparable to that of a black hole. And since we are in no way able to manipulate the energy of a black hole, it also means that we are clueless when it comes to creating an energy source for a time machine. And again, we're not sure that time machines are possible. However, the theory of time machines that is allowed by Einstein's theory requires energy on a scale of a black hole, and that's simply not going to happen to us anytime soon. So sorry about that. So once again, yes, energy is the bottleneck preventing us from having many of the devices in the movies, for example, ray guns and jetpacks. But when it comes to time travel, we're talking about cosmic energy that we're not going to have for many a centuries or many a millennia. Okay, well, let's take the next listener phone call.
Hello, Dr. Kaku. This is Martin from Chattanooga, Tennessee. I'm listening on 102.3 FM WGOW. My question concerns the discovery of the Higgs boson. This is a particle that scientists think gives mass to objects. Do you think that we would theoretically be able to find a way to repel the Higgs field? And if we could, would this give us the chance to meet the speed of light or even exceed the speed of light travel? Thanks a lot. Bye-bye.
Well, I wish, but the short answer is probably no. First of all, the Higgs boson is central to what is called the Standard Model, which in turn is a byproduct of 50 years of investigation in terms of smashing atoms apart. We've been smashing atoms apart ever since World War II. Okay, and when we smash protons apart, what do we find? More particles. We find pi mesons, lambda mesons, k mesons, all sorts of junk coming out when we smash protons apart. However, we've been able to create a map or a zoo of these subatomic particles. It's not very pretty, but it contains 36 quarks, 3 generations of subatomic particles, 19 free parameters. It's a rather ugly theory, in fact, and it's called the Standard Model. The Standard Model fits all the particle data that we get from smashing protons apart, and allows us to reconstruct what might have happened at the instant of the creation of the universe when all these particles were in play. Now, what holds the Standard Model together is the Higgs boson. It was the last particle to be discovered in the Standard Model. And let's take a short commercial break. And after the break, I'll answer the question, can the Higgs boson allow us to go faster than the speed of light? For that, you'll have to wait till after the break. Once again, this is Professor Michio Kaku, and this is Science Fantastic. Give us a call at 866-323-2129, and you can share your thoughts on national radio. Leave your name, call letter to the radio station, and the city you're calling from, and perhaps your thoughts will be heard on over 100 radio stations that carry Science Fantastic. Stay tuned.
You're listening to Science Fantastic with Professor Michio Kaku. For more information on this and other great talk programs, go to talkradionetwork.com.
Want to invest but don't know what to do? In search of fixed double-digit rates immune to currency, real estate, and stocks? Discover the alternative asset Barron's magazine describes as lucrative and safe. An investment immune to Fed manipulation and low interest rates. Request your investor's guide. Call Cornerstone at 800-222-INFO. 800-222-INFO. That's 800-222-INFO.
Hi folks, it's a holiday season with hope in the air. Things to look forward to and no time for despair. Health can be a challenge, and so can the mail. So Get the Tea wants to help you by giving you a sale. Buy 2 months of Super Tea and get 1 month for free. No limit. That's buy 2 months of Super Tea and get 1 month free. That's a savings of $35. Where? GetTheTea.com. That's GetTheTea.com. Scroll down on the front page and find the buy 2 get 1 free ad. Click it and save. Orders over $100 get free shipping. Send the gift of life. Change tea at GetTheTea.com. We have many non-GMO organic supplements just waiting for you. This holiday season, enjoy health and Thanksgiving with GetTheTea.com. Want to call us? 928-308-0408. That's 928-308-0408. GetTheTea.com is a proud sponsor of doing what's right. That's GetTheTea.com.
I want to talk with you about evolution. It's actually a board game, and it's called Evolution: The Beginning. A few months ago, I played for the first time. I must say, it's a very clever game, and it's a new game, so I wanted to make sure that dear old Dad could play this game with the kids at Christmas. He can. Here is the goal of the game. Eat as much food as possible. Yes, to survive, you must eat. And to eat food, each player takes turn creating and evolving their very own species. There's hundreds of ways to evolve your species, and the fun part is, it's up to you. Evolution: The Beginning is based on science. Your species must adapt and change in order to be competitive, just like in life. Evolution: The Beginning is only at Target stores. So when you're at Target this week for last-minute Christmas gifts, go to the game section and get Evolution: The Beginning. It's a great holiday gift for your family, and it's all at Target stores. Evolution: The Beginning.
Hello, here I am, Roy Masters, 55 years on talk radio and still saving lives. Please continue helping the Foundation of Human Understanding by simply donating $19.95 per month. Paying it forward plan will continue saving lives into the years to come. I'm a pioneer in helping our troops to overcome the ravages of PTSD without drugs. Go to FHU.com and then click on the donation page. That's FHU.com.
The Foundation of Human Understanding is a 501c3 church.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. This hour is your hour. This is the time when you can shine by getting to the phones and giving us a call. The call number to make is 866-323-2129. Once again, that's 866-323-2129. All we ask is that you leave your name, call letters to the radio station you're listening to and the city you're calling from. And hey, you can have your thoughts heard on over 100 radio stations that carry science. Fantastic. And once again, no question is, quote, too dumb or too stupid to put on national radio. Sometimes the dumb questions are the most profound questions of all. Okay, so right along, let's take the next listener phone call.
Yes, this is Ray from Portland, Oregon, listening to 1190 KEX. You said that there is a positive and a negative in the universe to everyone and to everything. If there is a negative that an atheist says that there is no God, what is the positive that others can prove that there is a God or that he does exist? If you can explain that to us, the positive and the negative. Thank you.
Okay, well, when we talk about positive and negative, I was referring to the positive and negative particles of the Standard Model. And the previous guest asked a question about the Higgs boson. Let me quickly answer that question and then get into the other question of proving the existence of God. First of all, the Higgs boson is a particle that we discovered at the Large Hadron Collider, predicted by physicists over 30 years ago. In fact, I was a graduate student getting my PhD when I first heard about the Higgs boson, and the Higgs boson breaks the symmetry of the original Big Bang. Now, to do that, the Higgs boson starts off as a tachyon. A tachyon is a particle that goes faster than the speed of light, but because science and physics does not like particles that go faster than the speed of light, what it does is that it destabilizes the vacuum. In other words, the vacuum makes a transition to a lower state. Just like when you freeze something, it goes from one energy to a lower energy. And then the Higgs boson is tamed and becomes an ordinary particle that goes slower than the speed of light. So to answer the previous person's question, does a tachyon go faster than the speed of light? Only at the instant of creation. And after that, what it does what is called breaking the vacuum. It goes to a lower energy state. And in the lower energy state, it goes slower than the speed of light. So Einstein has the last laugh. You cannot have Higgs bosons going faster than the speed of light. Now, the Higgs boson has a charge. It has positive and negative charge. And we see that there's a balance between the positive and negative charges in the Standard Model. In fact, in the universe, there's a balance between positive and negative. Equal numbers of positive charge, equal numbers of negative charge. And why is that? Because we think that the Big Bang started off with zero charge. We think that the Big Bang, in some sense, started off as the vacuum. That is, nothing. Out of nothing came an entire universe. That's why the net spin of the universe is zero. If you take a look at all the galaxies of the universe, they're spinning in all directions, right? But let's add them up. When you add up all the spins of the universe, like spinning tops, what do you get? Bingo, zero. If you add up all the plus charges and minus charges of the standard, what do you get? Zero, bingo, once again. In fact, that's why we physicists believe that the universe may have come from nothing, because nothingness has positive and negative charges balancing out. Nothingness also has zero spin balancing out, and the total energy of the universe is probably also zero. Mass of the universe, of course, is positive because we have stars and galaxies, but gravity itself has negative energy. When you add the two together, what do you get? Bingo, zero. And so maybe the universe did come out from the mist, as some religious people and theologians have said. Maybe the universe was for free. The universe came from nothing. Zero charge because positive cancels negative. Zero spin because all the spins cancel out. And zero energy because gravity cancels the energy of matter. Now, can you use this to prove the existence of God? I don't think so. First of all, there is a website that I've complained about. In fact, there are quite a few websites in my name that I have no association with whatsoever. This website claims that I have a proof of the existence of God. If anything, I believe that it is impossible to have any proof of the existence of God. I personally believe that 1,000 years from now, we'll still have discussions as to whether or not you can prove the existence of God, which I think is basically unprovable one way or the other. You cannot prove or disprove the existence of God. First of all, disproving the existence of God is very problematic because it's very difficult to disprove a negative. For example, to disprove the existence of unicorns. It's almost impossible to disprove the existence of unicorns. Well, let's take a short commercial break. And after the break, I'll say a few things about unicorns and the existence of God. And if you want to get on Science Fantastic, give us a call. 866-323-2129 is the number to call, and you can get on Science Fantastic and share your thoughts on over 100 radio stations that carry Science Fantastic. So give us a call at 866-323-2129.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, it's open mic on Science Fantastic because this hour is your hour. This is the time when you can ask that question or make that comment that you've always wanted to ask but never had the courage. Well, you have the courage now. Get to the phones and call 866-323-2129 and have your thoughts heard on national radio. Well, before the break, we had a question about whether or not you can prove or disprove the existence of God. My own personal point of view is that you can neither prove or disprove the existence of God. First of all, disproving the existence of anything is problematic. If you want to disprove the existence of unicorns, you have a problem because no matter where you look, it's always possible that some place you haven't looked yet. It's always possible that you overlook some place. And so disproving a negative is always problematic. But also proving a positive is also problematic when there's no uniform definition of God. There's no criterion. See, in science, we believe in things that are testable, reproducible, and falsifiable. The proof of the existence of God or disproof of the existence of God is not testable, reproducible, or falsifiable. So it's like talking about unicorns or angels. Maybe they exist. Maybe someplace you will find an angel. Maybe someplace on earth you'll find a unicorn. But we have to be able to test it. And no one's been able to come up with a definition or a test of the existence of God that allows us to make measurements. So personally, I think that we have to keep the existence of God separate from science. In fact, I think Galileo said it the best. Galileo said that the purpose of science is to determine how the heavens go. The purpose of religion is to determine how to go to heaven. So in other words, religion is about ethics. It's about being a good person. It's about the standards for society of what is good and what is bad and what is legal and what is illegal. However, that's not natural law. The problem occurs when people in natural law pontificate about morals and ethics, or when ethicists and religious people begin to pontificate about natural law. That's when we get into problems. But as long as we keep the two separate, one, the domain of behavior, ethics, what is good, what is bad for society, and the other, the domain of natural law, I think there's no problem at all. Okay, well, let's move on to the next listener phone call.
Hello, my name is Sharon, and I'm from Florida. Clearwater. I would like to know, and I've asked a lot of people, and I don't think they know the answer, but they laugh. Why is the water blue, different colors blue in different parts of the world? And it's supposed to be a reflection from the sky. Well, where does the blue come from the sky? I like to know where the color blue comes from the sky to the water, but when you draw water up, it's clear. It's not blue. So I'd like an answer to this, and it's really navy blue out in the ocean. I'd just like to know where this color blue comes from. Thank you.
Okay, well, you ask actually a rather complicated question. First of all, why is the sky blue and why is the sunset red? That was first worked out by a physicist, Lord Rayleigh, in the last century by looking at the scattering of light. Light, of course, consists of Roy G. Biv, red, orange, yellow, blue, indigo, violet. So on one end of the spectrum, we have red. On the other side of the spectrum, we have blue. Now, it turns out that light scatters when it hits the atmosphere, and blue light scatters the most. Red light scatters the least, as proven by the physicist Lord Rayleigh. Now, when the sun sets, you're looking at the sun through an enormous amount of air, much more than when you're looking at the sun at noontime. At noontime, the light is not going through much air. But when you look at sunset, because of the geometry of the situation, you're looking at quite a bit of air to go through. And that's why the blues have scattered away, leaving red. Well, let's take a short commercial break. And after the break, we'll talk about why the sunset is red, why the sky is blue, and why the oceans are also blue. Once again, this is Science Fantastic with Professor Michio Kaku. Keep the calls coming at 866-323-2129 because this hour is your hour. This is a time when you can ask all sorts of goofy questions and get a reasonable answer from a physicist. Give us a call at 866-323-2129.
This is Science Fantastic. For more information on this and other great talk programs, go to talkradionetwork.com.
I want to talk with you about evolution. It's actually a board game, and it's called Evolution: The Beginning. A few months ago, I played for the first time. I must say, it's a very clever game, and it's a new game, so I wanted to make sure that dear old Dad could play this game with the kids at Christmas. He can. Here is the goal of the game. Eat as much food as possible. Yes, to survive, you must eat. And to eat food, each player takes turn creating and evolving their very own species. There's hundreds of ways to evolve your species, and the fun part is, it's up to you. Evolution: The Beginning is based on science. Your species must adapt and change in order to be competitive, just like in life. Evolution: The Beginning is only at Target stores. So when you're at Target this week for last-minute Christmas gifts, go to the game section and get Evolution: The Beginning. It's a great holiday gift for your family, and it's all at Target stores. Evolution: The Beginning.
Do you worry a lot? If you're forgetful, nervous, moody, or overwhelmed, chances are you're not protecting yourself from the ravaging effects of stress and anxiety. No matter the cause, ongoing stress and elevated levels of the stress hormone cortisol can rob your memory, your health, your quality of life, and your future. Now you can combat the effects of stress and anxiety while improving your memory and recall at the same time with the dietary supplement Calm and Clever. Studies show that the ingredients in Calm and Clever reduce cortisol by as much as 30% in as little as 1 to 2 weeks and increase your ability to recall facts, names, and numbers in 4 to 12 weeks. Calm and Clever was created by scientist Kurt Hendricks, a principal investigator in 2 NIH-funded studies on Alzheimer's disease. Try Calm and Clever for 2 months. You'll feel the difference. Call 1-800-758-8746 or go to calmandclever.com.
Hello, my name is Roy Masters. I'm an English veteran who's been witness to history and proud to become an American citizen. Because in America, free thought was encouraged and being truthful mattered more than being nice. My America was truly politically incorrect in all the best ways, which is why we were blessed. But things have changed, and Americans don't think American anymore. Even though I still speak with an English accent. My heart thinks American. My voice speaks American. And that is freedom. Please join me on my daily radio show Advice Line, Monday through Friday, and I will help you to reclaim our country. Let me help you find the courage to think and speak American again. Please download my radio show app, available now at the Apple App Store and Android Google Play. Thank you.
The Foundation of Human Understanding is a 501c3 church.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Keep the calls coming at 866-323-2129. You're not going to get a busy signal 24/7, anytime, day and night. You'll get a recording. Leave your name, call letters of the radio station, and the city you're calling from. And hey, perhaps you will be on national radio. Well, before the break, we had a question that a lot of people ask, and why is the sky blue? Why is the oceans blue, and why is the sunset red? And it's due to the nature of light scattering. When you look at the sunset, you're looking through a lot of air because of the geometry of the sunset, and blue light has scattered away because blue light scatters the most. It scatters the easiest. So when you look straight up, on the other hand, when you look straight up, you're looking at where light scatters the least. And because the atmosphere is the shortest distance when you look straight up. So that's why blues survive the scattering process when you look straight up. When you look at sunset, that's when you have light going through the most atmosphere, and the blues have scattered away, leaving the red. So once again, the spectrum of colors goes from red on one side of the spectrum to blue on the other. Blue scatters the most. And that's why when you look straight up, you're looking at scattered light. And scattered light is blue. So when you look away from the sun, don't look at the sun, of course, but when you look away from the sun, you're looking at scattered light. Now, if you don't believe me, turn off the light in your room. All of a sudden, everything's dark. Why is that? Because you're looking at scattered light almost all the time. You almost never look directly at the fluorescent lights. You almost never look directly at the sun. You're always looking at scattered light. And again, if you don't believe me, just turn off the light in your room. So when you look at the sky, you're looking at light that has scattered the most, and blue scatters the most. Now, it turns out that blue of the oceans is due to two effects. One, of course, the fact that the sky is blue, but second, water itself is slightly bluish in color. It turns out that the reds are absorbed by the vibrational bonds of H2O. H2O consists of two hydrogens and one oxygen. That's why it's H2O, and it vibrates. It turns out the vibrational frequency of this contraption called H2O absorbs reds, leaving, therefore, the blues. So now I want to talk with you about evolution, the beginning. It's actually a board game. Yes, it's a new board game you can play with your family, and it's called Evolution, the Beginning. A few months ago, the inventors of this game came by to visit. They wanted to show me how to play, and I told them very clearly, I want to make sure that dear old Dad can play this game with his kids when they open it Christmas morning. So we talked about the goal of Evolution, the Beginning. It's actually quite simple. Eat as much food as possible, because food counts for points in this game. To eat the food, each player takes turns creating and evolving their very own species. You can create long-necked herbivores that eat plant food, or you can create speedy carnivores that eat other organisms. There are hundreds of traits. It's up to you to decide what to create, and that's the fun. What I love is that Evolution, the Beginning is a game based on science. The game actually teaches about evolution because your species must adapt and change in order to be competitive and survive. The environment is dynamic. So every round brings new challenges and opportunities. You'll succeed if you can adapt to the changing environment. The goal of evolution, as in real life, is to be the fittest. And it's the same with this game, Evolution, the Beginning. So when you're at Target this week shopping for last-minute Christmas gifts, go to the game section and get Evolution, the Beginning. It's the perfect holiday gift for your family. You'll find it at all Target stores. Evolution, the beginning. Okay, well, let's take another short commercial break. Once again, this is Science Fantastic. Give us a call at 866-323-2129 and have your thoughts heard on national radio. So why should we scientists have all the fun? Why don't you just jump right in, give us a call at 866-323-2129, and you can get on over 100 radio stations that carry Science Fantastic. So stay tuned for the next segment of Science Fantastic.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open now. This means that you can give us a call. You're not going to get a busy signal. You can give us a call and leave a message at 866-323-2129. Well, before the break, we had a simple question. Why is the ocean blue? Why is the sky blue? And for that matter, why are sunsets red? And it has to do with the scattering of blue light. Blue scatters the most. Red scatters the least. Therefore, when you look into the sky, you're looking at scattered light because, of course, you're not looking directly at the sun. You're looking away from the sun, and therefore you're looking at scattered light, and that's why the sky is blue. However, when you look at the sunset, you're looking directly at the sun, looking at a large distance through the atmosphere of the Earth, and that's why the sunset is red. And the water is blue because, believe it or not, it has a bluish color. H2O is the chemical symbol for water, and it vibrates. The vibrational frequency corresponds to red. Therefore, red light is absorbed by water, leaving the blues. And that's why blue light is the light that you see when you shine light through water. Okay, well, moving right along, let's take the next listener phone call.
Yeah, hi, my name is John Lucas, calling from WMLI in St. Mary's, Georgia. Recently, NASA ran an experiment with an engine that used no fuel. It was done on the planet at ground level, and it produced positive thrust. Critics have said that they hadn't compensated for the extreme cold of space, and in fact, the heat outside the experiment, or outside of the machine, inside of the closed experiment, was causing the positive thrust. What are your thoughts? Thank you.
Yes, this is causing a certain amount of flutter on the internet, so let's make this clear. First of all, an electromagnetic engine is basically a chamber that has, let's say, radar or microwaves floating inside. So a primitive version of this would be your microwave oven. Now, the question is, can you use your microwave oven or an electromagnetic drive to drive a spaceship? Well, Newton would say for every action, there's an equal and opposite reaction. Therefore, the two cancel out, unless, of course, you harness it in the form of a rocket. So you have thrust on one side, and you have the propellant on the other side, and you have net thrust. That's the experiment that was done, causing a certain amount of controversy, because physicists would say that you should get zero, or something very close to zero. Now, the authors of this study claim that they get something very small but positive when it should be zero, which means that perhaps you can use something like radar or microwaves in order to drive an electromagnetic engine. Well, personally, and this is just my personal bias because I haven't done the experiment, my personal bias is that these people made a mistake, that Newton comes out ahead and the action cancels against the reaction and the thing does not move at all. However, I'm a physicist, and I realize that the ultimate arbitrator is not my feelings, but reality. So the test is going to have to be redone, but among the physicists that I know, uniformly we believe that a mistake has been made. However, who knows? We're always open to new ideas. Physicists are revolutionary conservatives. That is, for the most part, we're very conservative. We don't want to change the laws of Albert Einstein and the quantum theory for nothing. However, once a deviation is found, we accept it immediately once it's verified. So verification is what's necessary now. As Carl Sagan once said, remarkable claims require remarkable proof. So getting energy from nothing is, of course, a dream of many a scientist, going all the way back to the perpetual motion machines. But hey, personally, I think a mistake was made, but we have to make sure that the experiment is done once again and again and again. Of course, you don't want to build a rocket engine and turn it on and nothing happens, right? You want to make sure it works every single time. Okay, well, let's take the next listener phone call.
My name is Ken. I'm calling from Anchorage, Alaska. Radio station 750 KFQD. My question is regarding something I heard about Hitler back in his day trying to control gravity or anti-gravity. I'm not sure which. There's something about taking mercury and applying high amounts of electricity, I think they said. Can you talk about this? Something about the relationship between mercury and very large amounts of electricity in regards to anti-gravity formation. Anyway, I do love the show and wish you were on more. Okay, bye.
Okay, well, you ask an interesting question because during World War II, lots of cockamamie schemes were investigated by not just the Nazis, but also by the United States government, because who knows, if just one of these cockamamie schemes worked, it would change the course of World War II. And that's why Adolf Hitler worked on the V-1 rocket. He worked on the V-2 rocket. He worked on the jetpack. The Nazis had an operational jetpack straight out of Buck Rogers. The problem is that it didn't last very long and was rather useless as a military weapon. But Hitler also had the V-1 rocket when in the United States we didn't have any rockets to speak of at all. And also the V-2 rocket, a cruise missile. So yes, the Nazis were ahead of us, but when it comes to anti-gravity machines, no, I don't think they were able to get that. In the United States, there's talk about the Philadelphia experiment, where the United States was experimenting with these things. Again, I think it was a bogus story. So personally, I don't believe it. However, if somebody could have proof of this, I'll be more than happy to look at it. But at the present time, scientific consensus is, nope, neither the Allies nor the Germans were able to create anything close to an anti-gravity machine. Okay, well, that's it for Science Fantastic. Once again, you've been listening to Science Fantastic with Professor Michio Kaku. Be part of the fun. Get to the phones and call 866-323-2129 and go to my website. It's mkaku.org, mkaku.org, and find out what all the fun is about. Good day.
This is Science Fantastic. Black holes, the cosmos, space and time travel, science and technology. This is Science Fantastic with Professor Michio Kaku.
Great Scott. I know, this is heavy.
Theoretical physicist, the co-founder of string field theory, author of the international bestsellers Hyperspace, Visions and Parallel Worlds. Now, profiling the latest cutting-edge developments in science. Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the most amazing developments in science which touch our lives and change human destiny. Well, and once again, in this hour, we're going to throw the lines open because this hour is your hour. This is the time when you can get to the phones and give us a call, and you can be part of Science Fantastic. All you have to do is go to the telephone and call 866-323-2129. Write that number down, 866-323-2129. And all we ask of you, if you want to get on national radio, all we ask of you is that you leave your name, call letters of the radio station you're calling from, and the city you're calling from, and perhaps your thoughts will be heard on over 100 radio stations that carry Science Fantastic. And if you want to see a complete list of the radio stations that carry Science Fantastic, and if you want to know what I'm up to, go to my website. It's mkaku.org, mkaku.org, or go to my Facebook site at Michio Kaku. Facebook site has already had 3 million fans on Facebook or Twitter. You can follow me on Twitter, find out where I'm speaking and what's happening. And we have 500,000 people following me on Twitter. And once again, if you want me to sign your copy of my latest book, go to my website and find out where I'll be speaking. I speak around the country regularly. So find out what I'm up to by going to mkaku.org, mkaku.org. My latest book is called The Future of the Mind. It hit #1 of the New York Times bestseller list, now in paperback form. You know, things like telepathy, telekinesis, moving objects with the mind, reading thoughts, photographing dreams. This is right out of science fiction, but in the physics laboratory, we physicists can now do all of the above, funded by the United States Pentagon. The Pentagon has given us over $150 million to hook the living brain to an exoskeleton so that our troops, the wounded warriors from Iraq and Afghanistan, will have the gift of movement once again, perhaps bypassing a damaged spinal cord. So find out about Iron Man, exoskeletons connecting the brain to a computer in my latest book. And if you want to know all about time travel, space warps, if you want to know about the fourth dimension, if you want to know about antimatter rockets, get a copy of my book, Physics of the Impossible, which talks about the impossible from a physicist's point of view. And if you're curious about robots, curious about the future of space travel, curious about what's out there with regards to technology, computers, get a copy of my other bestseller, Physics of the Future. Well, once again, the lines are open. Give us a call at 866-323-2129. Leave a comment or question, and perhaps you can get on Science Fantastic. Maybe you're having dinner with the kids, and the kids ask you a question from their homework assignment that leaves you stumped. You're speechless. You don't know what to say to your kids. Well, what do you say is, I'm going to call Dr. Kaku. In fact, why don't you put your kids on radio? Put your kids on the phone and have them ask a question to 100 radio stations across the U.S. Okay, well, let's move right along and take the first listener phone call.
Hi, this is Katie Jones in Chattanooga, Tennessee, Radio 1150. And my question is, I phoned it in earlier, but I didn't leave all my information. But my question is, volcanoes, why can we not utilize them as things to drop in waste, garbage, maybe nuclear waste or chemical waste? And why would that not totally disintegrate those type of things and just utilize a volcano? Thank you. Let me know.
Well, you ask a very interesting question that we physicists have actually tried to explore, but unfortunately we have pretty much given up. We've looked at the possibility of waste disposal and things like that through volcanoes, lightning, hurricanes, all sorts of natural disasters, because of course we're talking about energy on a scale that we humans cannot create. A lightning bolt can generate hundreds of millions of volts of electrical energy. But the problem with all three, with volcanoes, lightnings, and hurricanes, is that they are unstable. They're largely unpredictable. What you put in sometimes comes out again in the wrong form. So, for example, take a look at nuclear waste. If you were to put nuclear waste in a volcano, well, temporarily out of sight, out of mind, right? You think you've solved the problem. But let's say there's another eruption, and all of a sudden you have all this radioactive material being lofted in the air as fallout, raining down on the people below. Not a good idea. Or lightning bolts. Yes, it is possible. We physicists have actually sent kites up, just like Benjamin Franklin. And when a lightning bolt hits the kite, yes, electricity does go down. But again, you're talking about a very unstable form of energy. When we want energy, we want to flick the switch and be guaranteed that it's not going to blow up in our face or blow out the fuses. And hurricanes, you realize that a single hurricane has more power than 100 hydrogen bombs. Look at the size of a hurricane. Hurricanes can go hundreds of miles in extent, while a hydrogen bomb can only perhaps wipe out maybe 10 miles or maybe 30 miles. So we're talking about a very powerful force of nature in terms of lightnings, hurricanes, and volcanoes, but unfortunately they are unstable. Now, of course, if you can figure out a way to stabilize that energy, perhaps you can be recognized as the next Thomas Edison. However, at the present time, we physicists have looked into these things, but we threw up our hands and simply said, too unstable for our commercial use. Okay, well, let's move right along to the next listener phone call.
Hello, Professor Kaku. This is Steve in Scottsdale, Arizona. Actually watching your radio show on channel CRN5 on Cox Cable TV. So my question is this. I understand that obviously 4% of the entire universe's mass is made up of baryonic matter. But my question is regarding dark matter versus dark energy. It was my understanding that, or at least I thought, that dark matter really comprised of all the unseen normal matter within that baryonic percentage, i.e. black holes, brown dwarfs, things that emit very low or actually no electromagnetic radiation, or at least can't be visibly photographed or seen. So the question is, does the current calculation of 4% baryonic matter comprise all of those other traditional dark matter masses like black holes and brown dwarfs, interstellar gas, dead wandering planets, all these dark bodies? Thank you so much.
Well, the answer to your question is no. Next question. Now, let me try to answer that question by breaking it down. First of all, what is dark matter? Dark matter is invisible matter. If you held it in your hand, it would be literally invisible, but it would seep right through your fingers because it has no interaction with ordinary matter. In fact, if you held it in your hand, it would go right through the crust of the earth, through the center of the earth, all the way to China, reverse direction, and come all the way back up to New York City, and would oscillate between New York and China as if the earth did not exist, but gravity does exist. Now, we know that dark matter is real. It's not science fiction. The Hubble Space Telescope and other telescopes have given us maps of the distribution of dark matter in the universe. It is 10 times more plentiful than ordinary matter. And if you were to figure out what dark matter is, you would win the Nobel Prize in Physics. If you ever discover what dark matter is, tell me first, and maybe we'll publish together and win the Nobel Prize together. Now, let's take a short commercial break, and after the break, we'll talk about baryonic matter, and we'll talk about, well, what is this dark matter that's forcing us to revise all textbooks? Most of the universe is not made out of atoms. All the textbooks are wrong and now are being rewritten. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 866-323 2129. Ask a question, make a comment, and perhaps you can get on over 100 radio stations that carry Science Fantastic. So let's take a short commercial break, and then we'll continue with Open Mic on Science Fantastic.
This is Science Fantastic. For more information on this and other great talk programs, go to talkradionetwork.com.
Are you a baby boomer? Afraid of stocks and commodity prices? Want to invest but don't know what to do? Discover the alternative asset class Barron's Magazine describes as both lucrative and safe. Discover high yields without market volatility. Request your investor's guide. Call Cornerstone at 800-222-INFO. 800-222-INFO. That's 800-222-INFO.
Hi folks, it's a holiday season with hope in the air. Things to look forward to and no time for despair. Health can be a challenge, and so can the mail. So Get the Tea wants to help you by giving you a sale. Buy 2 months of Super Tea and get 1 month for free. No limit. That's buy 2 months of Super Tea and get 1 month free. That's a savings of $35. Where? GetTheTea.com. That's GetTheTea.com. Scroll down on the front page and find the buy 2 get 1 free ad. Click it and save. Orders over $100 get free shipping. Send the gift of life. Change tea at GetTheTea.com. We have many non-GMO organic supplements just waiting for you. This holiday season, enjoy health and Thanksgiving with GetTheTea.com. Want to call us? 928-308-0408. That's 928-308-0408. GetTheTea.com is a proud sponsor of Doing What's Right. That's GetTheTea.com.
Having a place to go after school will make you a better student. Having an outlet to express yourself will make you a better artist. Having something to do together will make you a better family. At The Y, we're helping build better friends, listeners, writers, swimmers, scientists, and musicians, one chance at a time. Give the gift of opportunity. Donate to The Y at ymca.net/give. The Y, for a better us.
Do you worry a lot? Whether you're a college student, busy professional, parent, or grandparent, ongoing stress and elevated levels of the stress hormone cortisol can rob your memory, your health, and your future. Now you can combat the effects of stress and anxiety while improving your memory and recall at the same time with the dietary supplement Calm and Clever. Studies show that the ingredients in Calm and Clever reduce cortisol by as much as 30% in 1 to 2 weeks. Call 1-800-758-8746 or calmandclever.com.
Want to invest but don't know what to do? In search of fixed double-digit rates immune to currency, real estate, and stocks? Discover the alternative asset Barron's Magazine describes as lucrative and safe. An investment immune to Fed manipulation and low interest rates. Request your investor's guide. Call Cornerstone at 800-222-INFO. 800-222-INFO. That's 800-222-INFO.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open. It's open mic in this hour. This is the time when you can share your thoughts on national radio by giving us a call. The hotline number to call is 866-323-2129. All we ask of you is that you leave your name, call letters of the radio station, and the city you're calling from, and perhaps your thoughts can be heard on over 100 radio stations that carry Science Fantastic. Well, before the commercial break, we had a call coming in asking about dark matter and whether or not baryonic matter is within dark matter. And the short answer to that is no, but let me explain. Once again, dark matter is 10 times more plentiful than ordinary matter, but we are clueless to understand what it is really made of. At first, we thought it was dead stars, dark, invisible, things you cannot see. That's called baryonic matter. A proton is a baryon, a neutron is a baryon, atoms are baryons. So baryonic matter is a clever way of saying ordinary atoms. So we know that ordinary atoms do not make up most of dark matter. So then dark matter must be something that is not atomic. So all the high school textbooks are wrong. All the textbooks say that the world is mainly made out of atoms. Wrong. So what is the universe made of? Rather embarrassing, we don't really know for sure. Dark matter, we think, the leading candidate is that it's a higher vibration of the string. Now realize that these strings are very tiny. It's what I do for a living, in fact, working on string theory. Each vibration corresponds to a particle. And so it turns out that these vibrating strings make up all the atoms that we see around us, but it has higher octaves, octaves that don't look like atoms at all. And so we think that dark matter is nothing but a higher octave, a higher resonance of tiny little vibrating strings. And so once again, we think that baryonic matter, that is ordinary atomic matter like you and me, we are both made out of baryonic matter, that we make up only 10%. Actually, 4% is what the caller said, depending upon how you categorize matter in the universe. But it turns out that baryonic matter only makes up a fraction of the entire universe, that dark matter makes up 10 times more, but it's invisible, and we think that it corresponds to another higher vibration of the superstring. And once again, if you want to know more about dark matter, string theory, and what I do for a living, which is string theory, get a copy of my earlier books, Hyperspace and Parallel Worlds, which have a complete description of strings, dark matter, and it answers the question, what is the universe made of anyway, if the universe is not made out of atoms? Okay, let's move right along to the next listener phone call.
Well, the name is Theodore, and I want to know what the difference is between a uranium reactor and a thorium. I've heard that thorium, when I heard Edwin Teller, I think, talk, he said they're safer. Why aren't we building them? That's my question.
Well, you ask a rather embarrassing question. First of all, Edward Teller was the father of the hydrogen bomb, and he was actually my advisor when I was in high school. When I was in high school, I built an atom smasher, and it caught his attention. I was actually playing with antimatter when I was in high school, and Edward Teller knew exactly what I was doing when I went to the National Science Fair in Albuquerque, New Mexico, and he offered me a 4-year scholarship to Harvard, where I could then begin my career as a professional physicist. So I owe it all to Edward Teller. Now, you're right. If we had a chance to do it all over again, if we were back in the year 1945 or around 1950, that's when the so-called Atoms for Peace program got off the ground under President Eisenhower, and they had a choice. They had different ways of creating nuclear energy and nuclear power plants. One was thorium, and another one was uranium, cooling them with sodium, cooling them with liquid water. A variety of different kinds of reactors and fuel cycles were proposed. But then what happened was the Nautilus. Remember the Nautilus, the first atomic submarine? The Nautilus went underneath the North Pole and generated incredible headlines around the world. I mean, think about that. For the first time in human history, a submarine could go sailing right underneath the North Pole and visit the North Pole just as if there was just no inconvenience at all. Well, it fired up the imagination. Everyone said that, well, that's the future. And what was the Nautilus driven by? It was driven by uranium cooled by water. So these are called light water uranium reactors. And so we scaled up the Nautilus reactor to commercial size reactors, and that began what is now known as commercial nuclear power plants. That meant that we were wedded to a nuclear fuel cycle. The mining, milling, enrichment, waste disposal of uranium became the foundation not just of the weapons program, but also the commercial nuclear power plant program as well. Now, even back in the 50s, people were saying, well, not so fast, not so fast. Maybe we can cool the reactors with sodium. Maybe we can use a different fuel cycle based on thorium. Thorium reactors wouldn't melt so quickly, It's a whole different fuel cycle, but hey, that was 1950. In other words, it's really too late. The U.S. government and governments around the world have spent hundreds of billions of dollars perfecting the nuclear fuel cycle based on uranium, even though competing nuclear fuel cycles and competing methods could probably give uranium a run for its money. And so once again, thorium does have advantages. Thorium reactors will melt down, but they melt down much, it's more difficult for a thorium reactor to melt down, but it would take revising the entire nuclear fuel cycle on which nations have invested hundreds of billions of dollars. In other words, it's too late. It ain't gonna happen. Sorry about that. Decisions made back in the 1950s with the Nautilus are with us even today. So now I want to talk with you about Evolution, the beginning. It's actually a board game. Yes, it's a new board game you can play with your family, and it's called Evolution, the beginning. A few months ago, the inventors of this game came by to visit. They wanted to show me how to play, and I told them very clearly, I want to make sure that dear old Dad can play this game with his kids when they open it Christmas morning. So we talked about the goal of Evolution, the beginning. It's actually quite simple. Eat as much food as possible, because food counts for points in this game. To eat the food, each player takes turns creating and evolving their very own species. You can create long-necked herbivores that eat plant food, or you can create speedy carnivores that eat other organisms. There are hundreds of traits. It's up to you to decide what to create, and that's the fun. What I love is that Evolution, the beginning, is a game based on science. The game actually teaches about evolution because your species must adapt and change in order to be competitive and survive. The environment is dynamic. So every round brings new challenges and opportunities. You'll succeed if you can adapt to the changing environment. The goal of evolution, as in real life, is to be the fittest. And it's the same with this game, Evolution, the beginning. So when you're at Target this week shopping for last-minute Christmas gifts, go to the game section and get Evolution, the beginning. It's the perfect holiday gift for your family. You'll find it at all Target stores. Evolution, the beginning. Once again, you are listening to Science Fantastic with Professor Michio Kaku. If you want to be part of the fun, give us a call. The hotline number is 866-323-2129. Once again, 866-323-2129 is the number to call. Leave your name, call letters of the radio station you're listening to, and the city you're calling from, and perhaps your thoughts will be heard on national radio. So stay tuned as we continue with Open Mic on Science Fantastic.
This is Science Fantastic. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. That's right. If you want to get on national radio, if you want to make a comment or question on over 100 radio stations across the U.S., this is your chance. All you have to do is call that magic number, 866-323-2129. And what do we ask of you? All we ask of you is that you leave your name, call letters of the radio station you're listening to, and the city you're calling from, and yes, perhaps you'll be able to get on national radio. And once again, you may want to tune into my website. Go to mkaku.org, mkaku.org. Find out what I'm up to, because I'm always traveling around the country, and perhaps I'll sign your copy of my latest bestseller, that is The Future of the Mind. And afterwards, you can go to eBay and auction that book off for money. Yes, you can actually make money off this radio station because autographed books are worth something. And so find out what all the excitement is about by going to my website, mkaku.org. Once again, if you want to get on Science Fantastic, give us a call. The hotline number is 866-323-2129. Okay, moving right along, let's take the next listener phone call.
Yes, I have a question regarding radio astronomy. If you're detecting a cloud of, say, carbon monoxide, 2 to 1, a pretty simple cloud, it's, say, radiating at 80 Kelvin, how is it that we're able to discern discrete frequencies from these molecules, the rotational or vibrational states? Because the cloud has got depth and you've got all these molecules that are radiating these spheres at the same time, so wouldn't you would just have a signal of white noise versus a discrete frequency? The concept is a little, I guess, eludes me, and I'm not it's always eluded me, and I was just curious if you might know the answer, or have an idea. Okay, thanks. Bye-bye.
Okay, well, you ask a very interesting question that actually goes to the heart of radio telescope technology and the quantum theory and nuclear magnetic resonance machines. It turns out that, yes, when you take a look at a molecule, like let's say, for example, H2O, H2O has two hydrogen atoms combined with one oxygen atom, and there are many ways to vibrate it. So think of H2O made out of Tinker Toys and combined with a spring, and then you can move the spring in different ways. You can rotate the molecule, or you can stretch it and vibrate it. Now, this is where the quantum theory comes in. It turns out that not all vibrating frequencies are possible. They are quantized. In fact, that's where the word quantum comes from. They occur in discrete packets. These are called resonances. And so in other words, you're not going to get white noise, that is, bunch of gibberish. White noise on a microphone sounds like this. Shh. Random white noise. You cannot distinguish individual frequencies. But you see, the vibration of the molecule is quantized. Certain resonances are not allowed. Other resonances are possible. Think of, for example, a snake that bites its tail. If the snake were to vibrate as it goes in a circle, then only certain vibrations are possible as multiples of the length of the snake. You can have vibrations that are perhaps half the length of the snake, or perhaps a third, but we're talking about integer numbers of modes that the snake can vibrate along. Not all vibrations are allowed. That's how we're able to distinguish molecules from the cloud of gibberish that we get from outer space. So let's say we're looking at a star. We're looking at a distant star. So how do you know what the star is made of? Well, you look for resonances. Atomic resonances, molecular resonances that vibrate at distinct frequencies, a fingerprint of a certain molecule. For example, when you turn on your microwave oven, have you ever noticed that things bake from the inside out rather than the outside in? When you bake a potato, you're used to having that golden crisp on the outside because convection currents heat the outside first, and then the energy slowly goes to the inside. But in a microwave oven, it defies common sense because it heats from the inside out. And how's that? Because microwave radiation will penetrate right through the potato, and it energizes the molecular frequencies of the water vibrations. That's right, it's the water molecule that vibrates at a specific frequency that you hit with your microwave oven. So it's not white noise at all. It's a very discrete frequency that allows you to excite the water molecule, and that's how your microwave oven works. Okay, let's take another short commercial break, and after the break, we're going to continue with Open Mic on Science Fantastic. Give us a call. The hotline number is 866-323-2129. So be part of the fun. Find out what all the excitement is about. Get to the phones and call 866-323-2129. Leave your name, call letters of the radio station you're listening to, and the city you're calling from, and perhaps you can get on Science Fantastic. Give us a call.
This is Science Fantastic. For more information on this and other great talk programs, go to talkradionetwork.com.
I want to talk with you about evolution. It's actually a board game, and it's called Evolution: The Beginning. A few months ago, I played for the first time. I must say, it's a very clever game, and it's a new game, so I wanted to make sure that dear old Dad could play this game with the kids at Christmas. He can. Here is the goal of the game. Eat as much food as possible. Yes, to survive, you must eat. And to eat food, each player takes turn creating and evolving their very own species. There's hundreds of ways to evolve your species, and the fun part is, it's up to you. Evolution: The Beginning is based on science. Your species must adapt and change in order to be competitive, just like in life. Evolution: The Beginning is only at Target stores. So when you're at Target this week for last-minute Christmas gifts, go to the game section and get Evolution: The Beginning. It's a great holiday gift for your family, and it's all at Target stores. Evolution: The Beginning.
Do you worry a lot? If you're forgetful, nervous, moody, or overwhelmed, chances are you're not protecting yourself from the ravaging effects of stress and anxiety. No matter the cause, ongoing stress and elevated levels of the stress hormone cortisol can rob your memory, your health, your quality of life, and your future. Now you can combat the effects of stress and anxiety while improving your memory and recall at the same time with the dietary supplement Calm and Clever. Studies show that the ingredients in Calm and Clever reduce cortisol by as much as 30% in as little as 1 to 2 weeks and increase your ability to recall facts, names, and numbers in 4 to 12 weeks. Calm and Clever was created by scientist Kurt Hendricks, a principal investigator in 2 NIH-funded studies on Alzheimer's disease. Try Calm and Clever for 2 months. You'll feel the difference. Call 1-800-758-8746 or go to calmandclever.com.
Hi folks, it's a holiday season with hope in the air. Things to look forward to and no time for despair. Health can be a challenge, and so can the mail. So Get the Tea wants to help you by giving you a sale. Buy 2 months of Super Tea and get 1 month for free. No limit. That's buy 2 months of Super Tea and get 1 month free. That's a savings of $35. Where? GetTheTea.com. That's GetTheTea.com. Scroll down on the front page and find the buy 2 get 1 free ad. Click it and save. Orders over $100 get free shipping. Send the gift of life. Change tea at GetTheTea.com. We have many non-GMO organic supplements just waiting for you. This holiday season, enjoy health and Thanksgiving with GetTheTea.com. Want to call us? 928-308-0408. That's 928-308-0408. GetTheTea.com is a proud sponsor of Doing What's Right. That's GetTheTea.com.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. We're throwing the lines open because this hour is your hour. That's right. This is the time when you can get to the phones. Call 866-323-2129 and share your thoughts on national radio. Just leave your name, call letters of the radio station you're calling from and the city you're calling from, and perhaps your thoughts will be heard on over 100 radio stations that carry Science Fantastic. So it's open mic in this hour. So let's take the next listener phone call.
Hi, this is David. I'm calling from Meridian, Mississippi. And I was just going to ask you a question. And, well, the question is, if you were to fly around the globe and then land where you took off from, how far circumference would that be?
Well, the Earth is roughly 8,000 miles in diameter. And in high school, we realized that the circumference of a circle, you have to multiply by pi, 3.1419 ... So that means that the circumference of the Earth is 24,000 miles. Now, if the Earth is 24,000 miles in circumference, and it goes around completely in 1 day, that's 24 hours, That means that you are traveling at 1,000 miles an hour doing nothing. That's right. Just sitting on your rear end, you are moving at 1,000 miles per hour because it's 24,000 miles being the circumference of the Earth, and it takes 24 hours to go 24,000 miles, and therefore you, believe it or not, are traveling at 1,000 miles an hour doing nothing. Absolutely nothing. Okay, well, let's take the next listener phone call.
Hello, Professor. My name's Mark Chilbury. I'm phoning from Southampton in the UK. I'm listening via the web. My question is, why don't robots seem to follow Moore's law and advance as fast as computers do? It just seems a little strange to me. Thanks for your time.
Well, you ask a very, very important question because, first of all, Moore's law simply states that computer power doubles every 18 months. That simple statement has energized the world economy, created social media, changed the way nations behave, and changed the way we communicate with other people. That simple statement that computer power doubles every 18 months. But artificial intelligence, that is robots, do not obey Moore's law. And therefore, we are in a situation where we expect robots to be helpers with robot maids and butlers, but we don't have them. After the commercial break, I'll tell you why. Once again, this is Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 866-323-2129. And after the break, I'll answer the question, why don't we have robots? After all, we have everything else. Why not artificial intelligence? And maybe that's a good thing, because if we did have smart robots, perhaps they would push us out of the way and the robots may take over. So stay tuned.
This is Science Fantastic. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. This means you're not going to get a busy signal. You'll be able to get right to us by giving us a call at 866-323-2129, because it's open mic on Science Fantastic. Now, all we ask of you is that you leave your name, call letters of the radio station you're listening to, and the city you're calling from. And yes, perhaps your thoughts will be broadcast on over 100 radio stations that carry Science Fantastic. So here's your chance to ask that question that's always been bothering you. Here's your chance to get it off your chest, whatever it is concerning science and technology. And, well, before the break, we had a very interesting phone question. And that is that we're so used to Moore's law that computer power doubles every 18 months, we simply take it as our birthright that every Christmas toys are twice as powerful as they were in the previous Christmas. So, he asks, how come we don't have mechanical maids and butlers? Or for that matter, how come we don't have robots like in the Terminator? Robots that kill humans and take over the world. And so they'll put us in zoos, throw peanuts at us behind bars, and make us dance, just like we make bears dance behind bars today. What's the problem? Well, the problem is, first of all, why do we have Moore's law? We have Moore's law for the simple reason that we can etch tinier and tinier transistors on wafers of silicon using ultraviolet radiation. So we're very good at manipulating ultraviolet radiation. We're very good at manipulating silicon wafers. So bingo, that's the easy part. But you see, thinking does not obey Moore's law at all. We've been spoiled into thinking that everything obeys Moore's law. Nope. It's only the etching of transistors with ultraviolet radiation on silicon chips. That's it. period. That's all that obeys Moore's law, and that alone has changed world history. So we assume that everything else must obey Moore's law, but no, cognition, thinking, reasoning, self-awareness, consciousness, all these things are extremely difficult. Now, adding machines, of course, do obey Moore's law. That's why we have very powerful adding machines giving us the illusion that robots are thinking. Actually, they're not thinking at all. They're just very, very fast adding machines, but they don't have self-awareness. They don't have creativity. They don't have innovation because, of course, they require much more complicated algorithms than simply those found in adding machines. Now, why should you care? This is because the job market is going to be determined by this kind of technology. So why should you care? Because the future of society depends on that question. So in other words, the jobs of the future that are going to be obliterated, wiped out, literally wiped out, are repetitive jobs. Jobs that simply require bean counting, jobs that are repetitive, those jobs are going to be gone. Factory work, garment work, things that can be automated. Those jobs are going to be gone in the future. Middlemen jobs are also under pressure. That is, agency jobs, brokerage jobs, jobs involving inventory. Those jobs are going to be endangered because they involve adding machines. And that's what robots are. They're very sophisticated adding machines. So what are the jobs of the future? The jobs of the future will be jobs that involve pattern recognition. That is, recognizing voice, handwriting, faces, pattern recognition. Second, common sense. Understanding the way the world is put together, common sense. Also, interaction with humans, and also self-awareness. These four things robots cannot do at all, which means that, for example, gardeners, construction workers, policemen, they'll have jobs in the future because every construction site is different. Every garden is different. Every piece of garbage is different. Every crime is different. Those blue-collar jobs will survive in the future because they involve pattern recognition. Certain jobs that are middle class will be obliterated, like agencies. For example, brokers, stockbrokers. When you go to the stockbroker, you no longer buy stocks anymore at the stockbroker's office because you buy stocks on the internet. So why do you go to a stockbroker? Because you want intellectual capital, common sense, reasoning. You want to know who has the most experience, who's the most innovative, who knows the latest gossip, who has the best analysis. That's why you go to a stockbroker. Not to buy stocks, heaven forbid. You do that on your wristwatch. No, you go to the stockbroker because you want something that robots cannot provide, intellectual capital. So some jobs are going to be obliterated. For example, paralegals. They're going to be obliterated because paralegals mainly use search engines. And search engines, well, computers are great at search engines. But lawyers will have jobs. That's the bad news. Lawyers will have jobs in the future because lawyers have to argue to juries. They have to talk to judges. They have to understand state laws and federal laws, which change all the time, depending upon human nature and human mores. So in other words, lawyers will have jobs in the future, even though paralegals may not. And if you want to know more about this, get a copy of my book, Physics of the Future, where I list the jobs that will flourish in the future and also tell you about the jobs that are going to be wiped out as well. Okay, well, unfortunately, that's it for Science Fantastic. Once again, go to my website, mkaku.org, to find out what I'm up to. And again, my Facebook site has 3 million fans. On Twitter, we have 500,000 fans. Find out what the excitement is about by going to my website, mkaku.org, mkaku.org, and give us a call. The hotline is open 24/7, anytime, day or night. The number to call is 866-323-2129. Find out what all the excitement is about by calling 866-323-2129. And remember, every week we discuss the cutting edge of science, science that touches our lives. Good day.
helping you stay in the know. This is the PSN News Network and psnnews.net. From around the country and around the world, we bring you the latest news from the Associated Press. The PSN News Network will keep you informed. Updates are also available throughout the day on www.psnnews.net. The PSN News Network, psnnews.net, and the Associated Press. When you want to know.